In this video, we are going to review 8 exercises related to Chapter 5. So first question, which of the following is a Lewis base? So Lewis base is electron pair donor, which means that Lewis base must have free electron pair. Free electron pair may or may not be indicated. You need to know Lewis structure, and so you need to know which atom has and which does not have free electron pair. So A is boron. Boron does not have free electron pair, it actually has an empty orbital. It's a Lewis acid. B is Bronsted acid, it's source of proton, hydrogen chloride. C, that's a Lewis base because there is free electron pair on nitrogen. And D is carboxylic acid, that's an organic acid, proton source. So correct answer is C, that's compound with free electron pair. Question number 2, which of the following is Lewis acid? So Lewis acid is species with an empty orbital. And among the 4 species here, A, boron trifluoride, has an empty orbital on boron. So that's Lewis acid. We can check the rest just to make certain that we are correct. So B is ammonia, so that's actually Lewis base, free electron pair on nitrogen. C, students often pick this one because there is positive charge on nitrogen. But positive charge is not related to whether something is Lewis acid or not. Frequently Lewis acid carries positive charge, but not necessarily. And not all positively charged species are Lewis acids. And in this case, ammonium cation is not Lewis acid. It's proton source, so it is Bronsted acid. And of course, as a proton source, H plus is Lewis acid, so it may be considered to be source of Lewis acid, but still it's not Lewis acid. And D is conjugate base of carboxylic acid, so clearly not a Lewis acid. So correct answer is A. Question number 3, which of the following substituents increases strength of an acid? So a substituent that is more electronegative than carbon increases strength of the acid, and less electronegative substituent decreases strength of the acid. Substituent A is isopropyl group, so it's an alkyl group. Carbon, of course, carbons have same electronegativity, but hydrogens are present as substituents and they are less electronegative than carbon. So the more alkyl groups we have, the more CH bonds we have, the weaker the acid, because those are actually electron donating substituents. And so isopropyl group will actually decrease strength of the acid. B, we have boron, BH2. Boron is less electronegative than carbon. That's also going to decrease strength of the acid. C, cyclopentyl group, again a lot of CH bonds or carbon substituents, that also decreases strength of the acid. D, bromine, that's more electronegative than carbon. This substituent is more electronegative than carbon, so that one increases strength of an acid. Question number 4. Water is a stronger acid than ammonia due to A, resonance effect of oxygen atom. That's not correct. Resonance effect is effect that spreads through pi bonds. Neither water nor ammonia have pi bonds, so resonance effect cannot operate here. Inductive effect of oxygen atom. Oxygen atom does exhibit a negative inductive effect, but it does not play a role here. It only plays a role when spreads through chain of carbon atoms. Differences in bond energies. Well, that's ultimately correct, but differences in bond energies are consequence of other factors that affect acid strength, so that's not really a correct answer. Finally, differences in electronegativities between nitrogen and oxygen atoms. That's correct answer, because more electronegative atom will result in conjugate base that better tolerates negative charge and is more stable, therefore weaker conjugate base. That means ultimately then stronger acid. So D is correct answer here. Question number 5, which of the following carboxylic acids has the lowest pKa value? So the lowest pKa value means strongest acid. So really this question means which of the following carboxylic acids is the strongest. Highest pKa value would be the weakest. So we have acetic acid that is substituted with bromine A, fluorine B, iodine C, or unsubstituted. The more electronegative substituent is, the stronger the acid, since they are all equal distance from carboxyl group. And the most electronegative substituent is fluorine, and so this is going to be the strongest acid. 6. Arrange the following compounds in the order of increasing acidity, from the weakest to the strongest. It's the best to answer this question on piece of paper, and anyway you should have pen and paper so that you can work as you are doing the test. So answer it on a piece of paper and then match your answer with one of these offered answers. So we are looking for the weakest acid. So 1 has fluorine very close to carboxyl group. That obviously cannot be weak. That's pretty strong. 2 has bromine, and it's actually on carbon 3. If carboxylic carbon is carbon 1, bromine is your carbon 3. So it's less electronegative than fluorine and further away than fluorine. That's definitely weaker. So 2 is definitely weaker than 1. 3, that's chlorine, more electronegative than bromine, and closer to carboxylic acid, so stronger. So far 2 is the weakest. And 4 has chlorine in the same position as bromine, but chlorine is more electronegative. That means 2 is the weakest acid. So you would write down 2 as the weakest acid. Then second weakest would be 4, because that's chlorine. It's the furthest away of the remaining substituents. Then in the order of strength, next would be compound 3, chlorine, in position 2. And finally, the strongest would be fluorine in position 2. So order is 2, 4, 3, 1, and that matches answer D. So correct answer is D. Next question is about a definition of resonance effect. So you have 4 statements, and which one correctly defines resonance effect? So a resonance effect is the displacement of electrons along a pi bond. That's correct. That's the definition of resonance effect. B, the displacement of electrons along a sigma bond is definition of an inductive effect. C, doesn't make much sense. Transfer of electrons from pi bond to a sigma bond. That may be some bond forming reaction in the course of reaction, organic reaction, but not electronic effect. Finally, D, tendency of an atom or a group to attract a shared electron pair is definition of electronegativity. So B and D are distractors. For students who did not study much, but remember some definitions, just don't remember which definition relates to which concept. A is correct answer. Finally, provide a structure of the conjugate base of the acid shown below. Conjugate base is the protonated acid. Therefore, you have to remove proton, and then, of course, remaining species will have negative charge, since in this case, starting acid is not charged. Loss of proton, positively charged species, will result in an ion. So the only trick is to determine which proton to remove. What is the acidic proton? And so acidic proton is one that is attached to oxygen, so conjugate base is, in this case, carboxylate, corresponding carboxylate anion. And this completes Chapter 5 exercises.